We're back, and I didn't realize I was running out of time on that last video, so it got cut off, but I was aware of that. So we'll overlap a tiny bit. So we were on this part of the outline, and we were just raising the question about what the net energy balance is for the various states in our region and a little beyond it, and make some comments about that. So what we're going to do is now click back over here to that graphic that we found on the energy information site. And by the way, if you ever want to do a paper or report on energy in the United States and you need some data, EIA.gov is a great site. It's the best one. It's the official governmental site. Really great stuff. So, so this is 2018, and so let's look at the balance first of all. So for Washington, in terms of units of energy, and let's not worry about the actual units, what these are here, but just rather look at the balance of them, okay? So with Washington, the consumption is roughly double the production. What do you think about Oregon? Okay, about the same, okay? Maybe even a little less, more dependent, okay? So got plenty of hydro, and some wind, but that's about it, okay? How about Idaho? Idaho is definitely a net consumer as well. In this case, about triple, so even more energy dependent. That's although Idaho, interestingly, has almost a purely hydro mix in its use of energy, some of which comes from the Columbia River nearby, some of the dams, and some on the Snake dams as well, and a few other places. So all three Pacific Northwest states, if we want to kind of define them as these are kind of the classic Pacific Northwest states. Now, there's little parts of Wyoming and Montana we could argue are Pacific Northwest without offending anybody, I don't think, and maybe some of Northern California, as I see it, maybe down almost to the Bay Area, something like that. But California's data are so big, as you can look at the numbers, are huge compared with Washington, Oregon, and they don't break it down by subregion. So we're going to ignore California. Even though we like Californians, we're just going to ignore them for now because we don't have good data for the part of California that pertains. So we're just going to look Washington, Idaho, and Oregon. Now, let's compare though, okay? So how about Montana? Now, you might recall, okay, really important, when we did the geologic history of the region, it used to be that the Pacific Northwest really went up to kind of the Idaho state line with Washington and Oregon, and that was about it. And it built out through subduction. We talked about that. So these areas here that are Rocky Mountain and a little bit on the other side of the Rockies, we're kind of going these particularly here. And maybe we can include North Dakota in that as well, kind of as kind of a nearby region. What we see here, yeah, I know it's a long ways from western to eastern Montana to the end of North Dakota. If you've ever driven that, that's a long ways. But in any case, check it out. Montana. Consumption is less than half of production. North Dakota, wow, look at that one. It's like 6+ times as much production as consumption. And you've probably seen trains, oil trains from North Dakota, by the way. And there's, by the way, some big coal fields in Montana, also Wyoming. Look at Wyoming's numbers, something like 12 times, more than 12 times as much production as consumption. So these are net energy exporting regions. And Colorado is too, if you want to kind of go down to the next level. Okay, so this landscape here is a landscape of fossil fuels. And by the way, if you kind of want to jump a little bit, look at, say, Texas and Oklahoma down below. Look at these numbers. Wow, big numbers, huh? Okay, and a lot of that is the oil industry and some coal and natural gas too, some big gas fields in Texas in recent times. Okay, but back up here. So these are net energy exporters and we're net energy importers. Do we import energy from them? Yes, we do, quite a bit, okay? And so, in fact, also they want to use us as a transshipment point. So that's something we're going to develop later on. So definitely on the other side of the mountains, there are these, if you recall in that geologic history, there were these shallow seas that gradually receded, but during the fossil fuel formation era, these were shallow seas and in some cases swamps. In the shallow seas, you get like oil and natural gas forming, and in the swamps, you also get natural gas and coal. And so when you find the big coal fields of Wyoming, for example, They have that kind of history. So this is then an enormous fossil fuel exporting region, and some of it goes through the Pacific Northwest. Okay. By the way, if we had Alberta up here, we'd have the same patterns we do with Montana, Wyoming. Lots of oil, some gas as well, and some, in fact, traditionally we've got most of our natural gas from the region, and then as well as Wyoming, and then also the oil sands or the tar sands up there. Okay, so let's go back then to our notes. So we know the answer to this, right? Okay, in fact, that was one of our original questions. Okay, so we are net importers of energy in the Pacific Northwest. So that leads to some interesting strategic questions, which we're going to look at later. What is our role in all of that? So just to kind of as initial answer that question a little bit, what's been happening in terms of change and net importing from other regions? I pulled up Oregon's numbers from 2012 and 2018, and this wrote them down. It was from the Energy Information Administration. And so hydro, we're about flat, okay? Basically, some of that has to do with how much snowmelt comes down the river, and some of it from Canada, varies some, and also whether we sell a little more or a little less each year. So we're pretty flat in terms of percent of total and amounts. You know, those are really not notable changes over the time period. Wind, actually, we didn't have less capacity, but we sold a little more probably in 2018. I don't have the exact data on that. The wind industry hasn't really installed much in the way of new wind farms in about the past 7 or 8 years here. I'm now speaking in the year 2020. Coal, interestingly, so there's been a decline, and coal is the dirtiest of the fossil fuels in terms of the pollution associated with not only its extraction, but also its combustion. And you can see a decline in actual megawatt hours generated, significant in that time period for Oregon, and that number will go to 0 in 2021. We talked about that, kind of, but not really, because we're still going to be importing for a while. In the winter, at least, we're going to be importing electricity from the east, from Montana, from the Dakotas, and so that's not really going to go away entirely, but the production will of electricity in Oregon from coal that came from somewhere else. And then the natural gas number. Now, here's the real story. So what do you want to make in your notes as what's notable in all of these numbers? This is one of the stories here. One hand, wind hasn't grown much in terms of our usage, but the other is, and coal has shrunk, but natural gas, what has it done from 2012 to 2018? Look at that. That is a huge increase. So pretty much you can just kind of straight across go, this decrease from 2012 to 2018, pretty much almost all of that came from natural gas. Now, coal and natural gas are both fossil fuels. So have we really made progress on our climate change combustions and the way we use electricity in Oregon over this time period? No, okay, we have not. Okay, so we understand that. Natural gas, now you could argue with some success that it's a cleaner fuel than coal, which is correct, but there's so much methane loss at some of the wells, and we still don't really have a good handle on how much that is with precision. So a lot of that is counteracted, and we're going to talk maybe a little about natural gas later on. But anyway, I thought you'd find that one an interesting table there. So how do we then think about these different energy resources and kind of compare, what to think about when we think about how we want to shape our energy future? And these decisions are made over time. States and regions do have policies, countries have policies, and even the globe has policies with the Paris Climate Accord. And so all of the criteria we look at here are used by people who do this kind of planning over time and strategic planning. So one obviously is price, okay? If you have a way of producing energy and it's very low cost, you have some advantages. That's not the whole story, of course, but that's a good starting point. So price matters, okay? And one of the problems of going back into the 80s and 90s, if you were trying to do something about climate change and you wanted to clean up, say, for example, the electricity supply, which has overwhelmingly, until this century, it had been from coal, one thing you could do would be to switch over to wind and solar. The problem up through about actually even into about 2008 or 9 is that both of them were so much more expensive than coal that you would have to have a huge government subsidy really to make it work, except in unusual areas. Price. That's changed, by the way. We'll get to that later. Another is where you get it from. Okay, if you can source your energy from nearby, it helps your local job and tax base. I think that's fairly self-evident. If we were sourcing all of our energy from nearby, then the jobs associated with harnessing or extracting that energy, whichever it may be, would be developing a local tax base and local job base. So there's an advantage to do it within the region. But it doesn't always make sense either. If it's way more expensive to do locally or regionally, then maybe consider somewhere else. Then there's always a question of foreign supply, okay? And this is a huge strategic issue for the United States, okay? Much of our spending on our military in the Middle East is in one way or another protecting oil companies, protecting the global economy from oil shocks, all of this. And so this is a huge spending strategy. Because it's strategic, we're willing to spend the money historically. If you just go back, look at Saudi Arabia from the 1930s on as a case in point, with the U.S. courting Saudi Arabia even up to the present. It's no accident, okay? Social and environmental externalities would be another thing to think about. And that's defined as when production and our utilization of a resource reduces social utility, in other words, the value to society, okay, or it reduces environmental health of the general population related to that, okay, where the total cost then of a particular resource use would be the market price that's paid and also the externalities as well. So a classic example would be something like, say, air pollution. And so the Southern California Air Pollution District was studied in late 80s and early 90s. And there was a study that came out in Science magazine, which is the world's most prestigious scientific journal, which showed that the annual cost of air pollution outbreaks in the Southern California Air Pollution District was $11 billion. And the way they came up with that number was actually fairly straightforward. They look at the difference between respiration problems, human respiration problems that happened over every day over a year, and then they looked at a graph of air pollution particulates in that same air pollution district, and the days when the pollution was higher, guess what? The healthcare related costs went up, and they basically just looked at a base level, and then they looked at air pollution outbreaks, and they said, what's the difference? They added all that up, and they came up with about 11 billion. It was not a controversial study. The methodology was so solid. Okay, that is an externality. And those who are out using those fuels, those who made profits extracting them and selling them and so on, didn't necessarily and generally didn't pay for the healthcare costs of those who suffered from it. So that would be one example of an externality, very real. Another externality that we experienced this summer, part of, not all, but part of our enormous air pollution outbreak related to the fires, and we've had more than one of these, but the summer of 2020, the September period was something else, wasn't it? And some of the worst air pollution in the world. There are health consequences to that. Now, I don't know, I'm sure there will be some work to try to figure out, to kind of put a number on that, and it will be argued about, which it should be. But there are real health consequences for some people, and that would be then an environmental externality, okay, of what? Of climate change. And climate change is caused largely by what? By fossil fuel consumption, or combustion rather. So what we're seeing is a changing world where we have much worse fires, whether it's Australia or California or the Pacific Northwest and other regions too. And those fires make a lot of smoke, and the air pollution does have health effects, okay? So there's a number there that we could estimate, okay? All right, so we'll come back to this on our next show here.